Hello, welcome to our semiconductor education program. I'm Vincent Chang. In this lecture video, I'm going to teach you MOS Cascode Current Mirror, Part 1, AC Analysis of MOS Diode. Here's the MOS Current Mirror you learned before, basic current mirror. If we duplicate the basic current mirror to the left-hand side as the first layer or first floor, and then on top of the first layer, we cascode a second layer like this. Then the output resistance will be increased. The performance will be improved. This is what we call the cascode current mirror on the left-hand side. Before we're supposed to dive in to analyze, to explain what exactly the output resistance is going to be. However, I want to do step by step. Pause my video. I want to do step by step. I want to give you a solid foundation, make sure you got every step right. So there's only one teaching objective: to know about the AC behavior of the MOS diode. The AC behavior of the MOS diode. We got two MOS diode. One is the Q1, another one is the Q3. The reason why we call diode is that through this configuration, it turns the three-terminal device into a two-terminal device, becomes a diode, MOS diode. So the question is, diode, two-terminal. When we do the AC analysis, we can replace the MOS diode with a resistance. Again, allow me to assume before you watch this lecture video, you already learned the other lecture video related to all the bipolar current mirror. So including this concept. So let's review. Let's review the AC behavior of the bipolar diode. What's the answer for this? Emitter-based collector, source gate drain. So emitter-based collector T equivalent. And the base and the collector becomes the short circuit, the blue line. Therefore, the resistance becomes the RE, or the alpha divided by GM, transconductance. Here's the answer for the bipolar diode. Let's go back to the MOS diode. What about the MOS diode? You could do the same thing. Source gate drain, and then source gate drain. Let's put on the T equivalent model. The resistance between source and drain looking into source is 1 over GM. And the current go this way. The AC current is IS, and then current control, current source. Current control and current source. And then we copy the blue short onto the T equivalent like this way. And then the current control current source is gone. Because the gate and drain degenerated, reduced to one terminal. So it becomes two terminal, 3 becomes two terminal, and the resistance is 1 divided by 1 over transconductance. All right? So this is the lesson. The equivalent resistance of the MOS diode equals 1 over GM. The takeaway is 1 over GM becomes the AC equivalent resistance of the MOS diode. So if you think about the cascode current mirror, the two MOS diodes, when you conduct the AC analysis, such as calculating the output resistance, you can simply replace the two MOS diode with the two 1 over GM resistance. Now, I want to give you a homework to think about before you watch the next lecture video, where we are going to analyze the output resistance of the cascode current mirror. If you do the analysis by inspection, just by inspection, if we only have the first layer, the output resistance of the mirror is what? Is R2, right? When you cascode, when you piggyback a second layer on top of the first layer, what the output resistance is going to become? This? Is this? Someone may naturally think is R2, then is series with R1. So R2 in series with R4. R2 plus R4. Is this correct or not? Analysis by inspection. Is this correct or not? Before you go on to the next lecture video, think about this. If this is right, just write down the reason why you think this is correct. Why R2 plus R4 is correct. Simply the series combination of the two individual output resistors. If you believe this is wrong, then put down the reason, your rationale, why this is wrong. What's the key point? All right? So we have come to the end of the lecture video. Thanks for watching.